Now directly from Italy, Gianluca Segalina is going to present bark thickness, stem straightness, and life history strategies in Pinus pinaster. Is there any trade-off between them?
Okay. Hello, everyone. So today we'll present the beginning of my PhD research. I will not give proper explanations to the research and to the results, but I will leave you with some questions. I hope you enjoy it. Okay, so nowadays we find different populations of Pinus pinaster in the Mediterranean region, which show a high genetic variability and high phenotypical variability. So you can see on your left, we have very straight pines, but going to the right, we have some populations that show very crooked stems. They're not straight at all. And our question is about study the variation of the bark along the stems and to see how it varies when the trees are subjected to some force, and it's actually our experimental design. And if the variations are the same towards different orientations. So here we have the map. This is a map with the populations we used. There are 7. Some are crooked, some are straight. And how you can see, we have close populations that show very different characters. So our experimental design, getting the seeds and the plants from those populations, is to use a common garden, which is in Valladolid. The design was random blocks, so they are very mixed together, all the 7 populations. In total, we studied 58 trees. So after 9 years of this common garden was going on, we applied an artificial bending to half of these trees, so 29 trees. The artificial bending was for 1 month, and then we released that. After 9 months from the releasing, we harvested the trees. So how did we investigate the bark? We used 4 points. We have the base level and 1 level at half of the tree height, more or less, on the below the 4th branch, and then 2 levels just below and above the top. So now I will show you the variables we used. So the variables are the area of the xylem as covariable to isolate the size effect. And then we used the bark area, the total bark area. Then we divided the bark area into 2 parts, only for the top. So we have north and south bark area. And then the last one was the maximum bark thickness towards north and towards south. And with 3 mixed linear models, I will show you now the results we got. So this is the first one, and I will talk about the differences between groups, between the straight group and the crooked groups. How you can see, in the control, we find very few differences between populations in terms of bark area. It was transformed to square root of bark area because of the variability of the data and to get a better result. So the only difference is only on the Y level of the trees. While when we bend it, we have this difference between groups which disappears. No, so we have actually a reduction of the Y level bark thickness, but we get an increase of the bark area on the A level, so on the top. So our treatment caused two variations. But when we analyze the maximum bark thickness, we see that again, as the previous graph, on the crooked ones, we almost have no effect. We just have effect on the north of the X, which is always a reduction effect. But more interesting is when we see the effect of on the straight, which confirms the previous model of the bark area. So we have, again, a reduction on both orientations of the maximum bark thickness, only on the straight group. And we also have a reduction on the X level, only to the south. The last one, this is the simplest model. It's only for the top level, from the A. So it's even more clear that the treatment affected the bark thickness on the A level, and it actually increased it. Increased it in both orientation, only for the straight group, and again had no effect on the crooked group. Okay, so now I will leave you with the discussion. So we recognized from the previous graphs that the treatment mainly impacted the straight trees and almost didn't have effect on the crooked ones. And so to make you think is why we got this reduction on the Y level, which is half of the tree height. And we have this increase after bending on the top. Thank you.